Okay, let's see how you did. With example number 18, this time the particle is moving along the y-axis, but the velocity is still v of t. It's a quadratic instead of a linear function like it was in the previous example. We're interested in the total distance which the particle travels over the interval from 0 to 4. So that means we're looking at the integral from 0 to 4 of the absolute value of our velocity. All right, so if we bring in the calculator, there's our velocity right there. Let me get it on the screen. There we go. So we can see that 2x squared minus 6x plus 4, same thing as 2t squared minus 6t plus 4. So we're going to go back to the main screen and math 9. And we have the integral that's happening from 0 to 4. We need the absolute value. So again, that's alpha window, option 1. And then we need our function, alpha trace, option 1. And our variable is x. So we have a dx right there. And give the calculator a second. And we see that we have 11 1/3 as the total distance which the particle travels. All right. Now we're interested in the particle's new position if we know that the particle was at -1 on the y-axis when t was equal to 0. We're interested in the particle's position at t equals 4. So in essence, y of 4 is equal to y of 0 plus all the change from 0 to 4. And the change in position is velocity, because velocity is the derivative of position. So this is what we're looking to solve. Now y of 0, we're told is -1. So what we really have here is -1 plus, and then that integral. So back to the calculator we go. And we're going to do -1 plus math 9. The bounds are still 0 and 4, but this time there is no absolute value. We just want the function. Right? Variable is still x, and we have 9 2/3 as our answer. All right. Now to number 19. Okay, particle moving again along the x-axis, but we have some trig involved. T cosine t. Find the total distance from 1 to pi. So we have, again, the integral from 1 to pi of the absolute value of v of t. That is our total distance. So in the calculator, there's v of t located in y1. So back to the main screen, math 9, from 1 to pi. Pi is second, and then the button above division, your exponent button. And we want absolute value, so alpha trace to bring up absolute value. And then we want our y1, which is, alpha window is absolute value, alpha trace is y1. All right, let's get that more on the screen. There we go. And we have our variable in terms of x. So we're going to get a little messier this time there. We see 2.759 or 2.60, but keep in mind that we want to go to at least 3 decimal places. So I'm just going to write here 2.7598. That way we're safe. You have to be accurate to at least 3 on the AP Calculus exam. All right, then we have part B. Same idea. What's the particle's position? So the particle's position, we're looking for x of pi. X of pi is going to be equal to x of 1 plus all the change from 1 to pi of our function. The change is the velocity. So we head back here, and we know that x of 1, we see there is -3. So we have -3 plus, and then math 9. The low bound is 1. The upper bound is pi. And our function, again, alpha trace. Right? No absolute value this time. Variable is still x. And when we hit enter, we see -5.381 or -5.382. If you're not getting these answers right here, but you have the same setup, there's a good chance that your calculator is not in the correct mode. So if you hit the mode button, you want to make sure that you are in radians for anything in regards to calculus. If you're in degrees, that works for physics or trigonometry, but it's not going to be helpful at all for calculus. We want to make sure that you're in radian measure. And if so, then you should be getting answers like these right here. All right, and then finally we have problem number 20. We have some more trig. This particle is back along the y-axis. We have to find the total distance. So we know the drill by now. Pi over 6 is the low bound, pi over 3 is the upper bound, absolute value of our velocity, dt. So the question you may have with this problem is, how do we get secant into the calculator? All right, so pre-calculus, we know that secant is the reciprocal of cosine. It's 1 over cosine. So on the calculator, what we're going to need to do is literally write 1 over cosine, but then wrap the cosine in parentheses and square it, and that will make secant squared. All right. So secant squared minus 2, as we see right there. And now we're going to go back to the main screen, clear those out, and we are going to do our Math 9 a couple more times here. So Math 9, and again, pi is located, it's the second, and then the caret button, so pi divided by 6, and then up here we have pi divided by 3, and we want the absolute value of our function dx. And if you came up with this answer right here of 0.309, that is a great answer. All right, so we have this is equal to 0.3094. Not a lot of movement at all by this particle. All right, but it's also not that big of a time of an interval, time interval, basically right there. Okay, and then we have here, we're going to say that y's value at pi over 3 is equal to y's value at pi over 6 plus the integral from pi over 6 to pi over 3 of our velocity function, no absolute value. All right, and at pi over 6, y's value is 1, so we're going to have 1 plus that integral right there. So we head back to the calculator one final time, and we're going to do 1 plus Math 9. We've got to enter in those pi's again. So pi divided by 6 and pi divided by 3, and our function dx, and the new position 1.1075. And that value is the new position at time t equals pi over 3.